Hello everyone, my name is Andrew. Today we continue learning Solidity, and today we'll talk about ERC20 tokens. So let's start. So what is a token? If you have some kind of utility, for example, you're playing a game, and in that game you can earn some coins in order to upgrade your character or do something with them. Then you have some utility in those coins, and each coin can be represented as a token. And basically a token is some kind of an interchangeable thing. So if you have 5 tokens, you can change them for another 5 tokens because they carry the same value. So it's like with the dollars. If you have $5 and $5 and another $5, you can just interchange them. There is no difference between them. Of course, there may be, but there is none in their value. And that's the most important thing. So tokens can be interchanged with each other and then they carry some utility. But what is ERC20? So ERC20 or ERC20 is a format for those tokens, because imagine that you have millions of applications and all those users write their own code. If you have some kind of an interface for all of the tokens, then what you can do is have the same functions, have the same code in order to interact with those tokens. And that's what the creators of Ethereum did. So they created an interface that allows us to work with the tokens in a similar way. That's just it. That's what the ERC20 is. And you can watch and read that EIPS article on Ethereum about why we need ERC20. But basically, as I said, we need them to have the similar interface in order to interact with the tokens. And also, the code that you have for ERC20 is not the code that you normally write. It's basically the code that you copy, maybe change some things and just deploy it, because ERC20 already has all of the functions, and all the functions that you ever need are already, well, not all of the functions, but most of them are already defined. So that's how it works. You'll probably just copy that code from that link, from Open Zeppelin contracts, where they have that ERC20 implementation, or you just you just copy the code and you change whatever you need. But most of the functions are defined for you. So let's talk about ERC20 and how it works. ERC20 is an interface, and in Solidity, interface is kind of like a class that allows you to just see what functions you want to implement, but it does not say you how those functions are implemented. For example, we can see function balance off that has owner as an argument, address, owner as an argument. It's an external function, so it basically means that it's a public function. So public function, anyone can call it except for the contract itself. So if I'm inside of ERC20 contract, I can't call balance off, but all the other people, all the other contracts can. So basically you can't call it from within the contract, but you can call it from anywhere else. It's a view, returns, integer, balance. And we can see that there are tons of those functions here, but none of them are implemented, because here in contract my token, we're saying that contract is an interface of ERC20. And here we just implement all of those functions. That's kind of how that works. So we have functions that are not implemented and we implement them later in our contracts. So let's talk about the functions themselves, because those are really, really important. First of all is balance off. Balance off is just a function that shows you what's the balance of your address. So what's the balance of that address that you provide in the parentheses. If we go lower, we can see that in my token contract I have balances mapping, and mapping is kind of like a dictionary in Python or object in JavaScript, and we have address that points to an integer 256. So address and the balance of that address. That's how it works. So balance of just returns you what's the address of your user using that, of your user or contract using that mapping. So basically just return it. We can go somewhere here, yeah, and balance of, as you can see, we just do balances from owner. Nothing very complicated here. Then we have the next function, which is called transfer. Transfer is a function that sends some token to another user or address. So user, contract, whatever. And here we have two parameters. The first one is address, so what address we want to send our tokens to, and the value is how many tokens do we want to send. Pretty simple. So if I want to send, for example, 10 tokens to my friend, I'm just saying, all right, transfer the address of my friend, 10 tokens. And my token will transfer those tokens to my friend. If you're interested where and how those tokens are used, USDT, wrapped Ethereum, Matic, wrapped Bitcoin, so millions of tokens are in ERC20 format. So those are really, really important. So because USDT, USD Tether, DAI, stablecoin, and all the other coins are typically using ERC20 format. Even if they don't, they have their wrapped versions. And the wrapped versions allow us to work with the tokens in one-to-one ratio without using the underlying asset. So for example, if you have a wrapped Bitcoin, you're working with Bitcoin and the price is the same, everything is the same, but that Bitcoin is not actually real. It's just like a wrapped Bitcoin. It's a token that allows you to, it's just like a wrapped Bitcoin. That's it. All right, so here we have transfer, very simple function, and then we have those three things. Transfer from, approve, and allowance. I'm going to talk about them a little bit later. Let's talk about events first. And events, approve, we're going to skip that for now. Event is basically a thing that allows you to gather intel on some action that happened in the past. So if something happened, you can use events in order to listen to those changes. For example, if I call transfer, then transfer event is going to be emitted. And I can basically say, all right, transfer event was emitted. I want to do something with it. So address from, address to, and unit value will be the variables inside of that event, inside of that transfer event. And I can do whatever I want with that data. That's how it works. So when we go to transfer, here it is, we can see that event is being emitted, and it's basically saying that something happened. That's pretty simple. All right, but what is transfer from, approve, and allowance? Well, basically in modern systems, transfer is not enough. So why is that? Because if you transfer to a contract, that contract does not understand that, oh, all right, I have 10,000 tokens from that user, or I have 5 tokens from that user. Because if you just transfer to a contract, that was stupid to implement. Imagine that each user that sends money to that contract, and each user sends money to that contract, and the contract itself has like a mapping of users and their balances. That's kind of stupid, and that wastes a lot of memory. Instead of that, we are using transfer from and approve system. So what is that? If I go to my token, you can see allowed here. And allowed is an address of mapping of address and unit 256. Because basically what we are saying is that we have people who allow other people to use their tokens. For example, if I want to exchange some tokens on Uniswap, the first thing that I need to do is allow Uniswap to spend my tokens. So I need to say, right, Uniswap, you can spend X tokens of on my account. Uniswap will say, all right, that's great. And I use approve function in order to say Uniswap, so spender, can use such value from my balance. You can use 10,000 tokens, you can use 1 million tokens, and so forth. And then Uniswap can call transfer from function inside of the functions that are required. So inside of all the functions where we need Uniswap to receive some tokens. For example, in swap function, I need to exchange USDT to Ethereum. What I'm calling is approve. I'm saying Uniswap, you can use 10,000 USDT on my account. And then Uniswap says, all right, now I will transfer that USDT from you to someone. So to my contract somewhere. So transfer from is a function that transfers from your address to your address and some value. So some amount of tokens. And basically that's it. We approve our tokens and then contracts transfer them whenever they need to. And it's much easier to work with transfer from, because if you have a function that is being called whenever you want to transfer your tokens, then you really, or your code can really understand that those tokens were transferred for that specific issue. And that's how it works. Of course, if you don't have enough allowance, and allowance is a function or a concept that shows you how many tokens are allowed for that specific address, if you don't have enough allowance in transfer from, it's just gonna fail. And that's why you gotta be really careful with approve, because if you have approved 1 million USDT on your account for some shady contract, it can just transfer it from you, and that's not what we want. Alright, so approval event is an event that is being emitted when you call approve function and you approve some value for another contract. Yeah, because once again, that address spender can be a user, can be a contract, can be anything. It's just an address. That's how it works. Now let's go to my token and you see the full implementation of that code. I'm not going to discuss about transfer from, balance of, approve, and allowance, because most of the functions are pretty simple. So in transfer from, we just get the allowance. If it's higher than our value, we increment the value of 2, we decrease the value of from address, and do some sort of stuff. But I'm going to talk about the things that really matter in that token, because all of those functions can be found on the internet. Yeah, you will not write transfer from, balance, and approve yourself. Well, probably. And even if you do, those are pretty simple. So like 4 or 5 lines of code. So let's talk about the first thing, which is max unit 256. I wasn't talking about that in the previous video because in Solidity we have problems with overflow of the integers. So if your integer is big enough, it can break your system. Not break your system in a sense that you have an exception, but break your system in terms of the arithmetic. So you can have an integer that goes from the max to 0, then you can have an integer that goes from the max to some another value, and that's not what we want. And max to int 256 is just used in transfer from and in transfer, I think. No, not in transfer. It's just used here in order to check that our math is correct. Because if it's not, then we're going to have problems with our tokens. So imagine I say I need to send 10,000 tokens, but user just receives 500 and your balance is decreased by 10,000. That's not, just not what we want. We want our math to be secure. And that's why we use max integer. I'm probably going to create another video on that safe math topic in Solidity because it's really, really important. Then we have balance and allowed. I already talked about those. And we have 3 things in here: name, decimals, and symbol. Name and symbol are not required, but typically you see them in the contracts. So name is your full name, for example, Tether USD, and the symbol is your ticker, USDT. But what is decimals? So in Solidity, we don't use floats. We can just say 0.1. I want to receive 0.5 USD. Instead of that, we're saying that we have decimals that represents, so 18 decimals, 1 and 18 zeros represent 1 token. As you can see here, we have 1 and 18 zeros, the same as in Ethereum. So if we're talking about Ethereum, we have Way, Ether, and all that stuff. Let me go to ETH converter, and you see that here we have Way. So if I have 1 Ether, it's that much Way. 1 multiplied by 10 in 18th power. And here, what do we have here? The same thing that with Ethereum. We don't have floats, we don't have doubles. Instead of that, we have a big value that represents 1 token. So that is 1 and 18 zeros is 1 USDT. If you want to send 10 USDT, then you just add another 0 at the end. If you want to send 15 USDT, you add 5 here. Pretty simple. Or wait, not here. Let me check. Yeah, not here, because that will be that value. You need to add 5 here. Basically, I am always using Ethereum converter because it's easier. So that is 15. Pretty simple. If you add it at the end, you will see that you have 0.000000001, something like that. And that's not what we want for now, but you get the idea. You can use floats or representation of floats without ever using floats directly. If you want to send 0.5 USDT, then just remove 1 0 and add 5 at the beginning. That's how it works. Pretty simple. And the last thing that we are going to talk about is balance, or initial balance of the user. So you need to send an initial balance of the user. There is a special variable for that. We don't have that variable here because that token is the simplest implementation of ERC20. But in more complex versions that you can find on OpenZeppelin website, you'll see that they have they have a variable that represents the total amount of your tokens. So how many tokens are there in existence? And what we are doing in our case is we are just saying that balance of MSG sender is some kind of a value. So that value represents the total amount of tokens, because if no one has a token, so if I just comment that that line out, no one has tokens. So how can I send them if no one has them? Not even the contract itself, no one. And that's why you need to have some kind of an initial balance in order to really send those tokens. And that may seem like a lot, but remember that we have 18 zeros in our code. So basically that's not how many, 1 billion, 1 trillion, that's just what, 100 USD? Yeah, 100 USD. So we have that as 1 and 2 zeros to get to 100. So 100 USD in here. That's not a lot. So that's how it works. All right, let's deploy this contract is abstract. Yeah, because we need to choose my token here, and let's deploy it. So you can see that I have my token here. We have all the functions. We can go to symbol, name, decimals, and let's first of all check the balance of our user. I'm going to copy the address that I deployed the contract from. Balance is all of the initial balance that I provided here. If I'm going to switch to another contract, you don't need to switch, but that's the only way I can copy my address. What I'm going to do here is paste it, and you can see that balance is... What happened? Let's copy it. Is that the right address? No, that's not. Balance is 0. Yeah, balance is 0. Nothing very cool here. Basically, we'll use balance off because in some implementations balances is private, but in that it's whatever. So balance or balance off. We can see that balance is 0, and I'm gonna switch to my first main account, so the creator of my token. And basically, why are you using message sender here? Because if you're using message sender in constructor, message sender is the creator of your contract. So who created the token has all the tokens by default. That's pretty simple. And what I'm gonna do here is use transfer. So let's open up that code. Let's get our second account. I'm gonna copy the address. So to address, and value should be, let's copy that big value. Let's transact. I'm gonna open up the console. Something is not alright. Token balance is lower than the value requested. Maybe I'm gonna copy that, paste it here. I don't know what's the problem. Did I choose? Oh, I did not choose the right contract, so the right address. I need to choose the address that has the tokens. Now let's transact, and everything's alright. So as you can see, if I don't have enough tokens, we have an error. Now I send some tokens to my second address. Let's go to that address. Let's copy the address of that wallet, and let's get our balance. As you can see, we have some balance, and the balance for our initial user was decreased. So let's copy it here. As you can see, 0. We don't have anything. That's how it works. That's the simplest implementation of ERC20 contract. Thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, and bye bye.